Alright, hey guys, this is lesson 6. I also have Arnold here.
Hi.
He is going to help us through this lesson. Anyway, so when we have set diagram, for example, we need to get from the given to the proven in a logical manner. Okay, and this is where those two column proofs come in play. Basically, the easiest thing to do is start off with your given. So just simply copy it down. Oh, I'm going to take care of it in one line. Let's see, AC bisects angle BCD. And again, the reason is going to be given. Number 2. Now, the goal here is to try to prove that these triangles are congruent. Okay? We need to use what's given to try to make some marks, congruency marks, and figure out that, these triangles are congruent. So, yes, Arnold?
Here's how it works.
Oh, I guess Arnold's going to walk us through it. So, oh, you don't want to? What are you going to do?
I want to ask you a bunch of questions. I want to have them answered immediately.
Okay, sounds like you guys. Arnold, just take a chill pill. Here, let me walk you through it, okay? So, based on what's given, we know BC is going to be congruent to CD. So let's mark that. BC is congruent to CD. Okay, now AC bisects angle BCD, which means it's going to cut it in half. This AC is cutting BCD, the whole angle, in half. So if it's cutting it in half equally, that means angle 1 here should be congruent to angle 2. So I'm going to state that. I'm going to say angle 1 is congruent to angle 2. And we're going to say definition of bisectors. Wait, someone's at the door. Back. Alright, I'm back, guys. So, third thing, let's see. We have a side and angle, and look, I think we can mark this side because of reflexive property. Because remember, we're trying to prove congruent triangles. We need to be working toward one of these 5 postulates. Okay? And this one's screaming at me. Side, angle, side, side, angle, side. That is exactly what we need to do. I'm going to state that AC is congruent to AC due to the reflexive property. So AC is congruent to AC because of the reflexive property. Now, the fact that I have all this stated and given, I can go straight to my proof, which is going to be triangle ABC is congruent to triangle ADC. Reason, side, angle, side. And we just talked about it. Excellent, excellent. Let's take a second, jot that down. Let's see, Arnold has something to say.
Trust me.
Alright, let's keep going. Again, I would take a second, draw the diagram. You can copy the given and proof over here, but I'd rather you just do it all in one shot, save yourself the trouble. So 1, we're going to say AB is congruent to ED. C is going to be the midpoint. I'm just going to put midpoint. Get it? Midpoint. Mid. Okay, you get it. BD. And last one is, well, I guess we got several. AB is going to be perpendicular. That's what that symbol means. To BD. And ED is going to be perpendicular to BD. Okay. Let's see here. Good, and all this again is given. It's not a 6, it's a G. So 2. Let's see what we got to work with. AB is congruent to ED, so I'm going to put a mark there and there. C is the midpoint to BD, so the midpoint is cutting this segment in half equally. So we know BC is going to be congruent to CD, so let's write that. So BC is congruent to CD because definition of midpoint. 3. What else can we take out of this? Well, perpendicular means these lines intersect at 90 degrees, so let's put a 90-degree symbol there and cheer. Okay, again, we kind of need to state that. In fact, I'm going to say that angle ABC is congruent to angle EDC and the fact that they're 90 degrees. You know, they're 90 degrees and they're congruent to each other. So we'll say definition again of perpendicular lines. Alright, 4. Now, if you look, I think we have enough information to say that these triangles are congruent.
Listen to me very carefully.
We're going to go side, angle, side, side, angle, side. So, triangle, we're ready for a proof. Triangle ABC is congruent to triangle EDC, and this is because of side, angle, side. Okay.
It's a beautiful day.
Alright. Let's move on. Next one. Again, pause the video if you need to, but go ahead and draw the diagram, and then start your statements and reasons. I'm going to continue writing the givens part, just like I've been doing. AB congruent to AC, AD bisects BC. And again, because it's given like that's like an arrow. Anyway, so we need to
look what we have here.
look at what we have here. That's right.
Just do what I tell you.
We're trying to solve for the triangle here, okay? So, let's mark what's given. AB is congruent to AC. That was easy. AD bisects BC. AD bisects BC. So it's cutting it in 2 equal halves. Okay? Now let's go ahead and state that. So let's get my blue pen. BD is congruent to DC. Again, because of definition of bisectors. 3. Well, I think we can pull out this idea. This is reflexive property, so let's go ahead and jot that down. AD is congruent to AD because of reflexive property. And then 4, we have everything we need, side, side, side. So again, bring the proof down. Triangle ABD is congruent to triangle ACD because of side, side, side. Oh. Again, go ahead and pause that. Let's see. Alright. So. Oh no.
What's going on?
Let's see what's going on. Again, I would jot down the diagram And then write down your given. Angle BAC is congruent to angle DAE, and AE is congruent to AC. Oh, and A is the midpoint to BD. All this again is given. 2. Let's mark what we got going on. BAC is congruent to D, over here, DAE. So BAC and DAE. It's the whole big angle there, okay? AE is congruent to AC, so AE is congruent to AC, alright? And A is the midpoint to BD. Well, A is the midpoint to BD. So that means this should be congruent to this side. So we made a lot of markings here, so let's clarify it in our statements. Here, let's take care of the BA and AD first. So BA is congruent to AD, again, because of definition of bisectors. Three, this is given that AE and AC are congruent. But you know, this reminds me of the overlapping segment theorem, but in this case, it's going to be the overlapping angle theorem. So we're going to take angle 1, it's going to be congruent to angle 3 because of overlapping angle theorem. 4. Now I'm going to make this green just to emphasize angle 1 is going to be congruent to angle 3. So now we have, whoops, not angle, that's a side, doi. Come on, erase it. Side, angle, side, and side, angle, side. So SAS. And again, just bring the proof down because we're ready for it. Triangle BEA is congruent to triangle DCA. Okay. So, are we looking good?
No problem whatsoever.
Good. Now remember, Cpctc is corresponding parts of congruent triangles are congruent. We'll talk about this in lesson 7 a little more, so I'm going to skip these. Y'all remember what an isosceles triangle is. Remember, legs of an isosceles triangle will be congruent. The base angles are going to be congruent as well. We'll talk about this later. I posted the answer key for you for this one. So let's try to do, let's see if I got a harder one in here. Let's see. Let's try to do some of these. Yeah. Let's do some of these. I'm going to do 31. Okay? Does that sound like a plan?
Yes.
Okay. Alright, so 1 is always going to be given. I'm just going to go ahead and write given because that's what it's going to be. C again is going to be the midpoint to AE. We got BA is going to be congruent to DE. And angle A is going to be congruent to angle E. My very next step is going to be looking for, or marking the triangles as far as what's given. So if you notice, BA is already marked for us, and DE is marked for us. Angle A and angle E is marked for us. Now they said C is the midpoint to AE, so they didn't mark these, so we'll mark them. AC and CE, so let's state that. We're going to say segment AC is congruent to CE. And again, because definition of midpoint. 3. Well, we have enough information now. Side, angle, side. Side, angle, side. I'm ready to start my proof. So triangle ABC is congruent to triangle EDC because of side, angle, side. Side, angle, side. Yep, holds true. Side, angle, side. That one's done. I'm just going to do 32 and end the video, okay? Does that sound like a plan, Arnold? In fact, what do you have to say to that, Arnold?
I want to ask you a bunch of questions. I want to have them answered immediately. No deal. Don't worry. That's amazing. Howdy, stranger.
Yeah, I came back. Whoopsie daisy. Alright, there we go. So we're done with 31. Let's do 32 and we'll call it quits. So again, given. Let's write given over here. R is going to be the midpoint of PT. Angle P is going to be congruent to angle T. And angle P, whoopsie daisy. Oop, what? Everything's being deleted. Angle PRQ is going to be congruent to angle TRS. And all that's given. 2. Yeah, let's mark up some ideas. Angle P and angle T are congruent. QRP and SRT is congruent, or TRS. I said it backwards. Okay. R is a midpoint again, so that means we can mark PR and RT. Let's write it. So PR is congruent to RT. And again, definition of midpoint. Now with that in mind, we have angle, side, angle. Let me write that. Angle, side, angle. Angle, side, angle. Kind of matches, so we're looking good. So proof triangle PQR is congruent to triangle TSR. Angle, side, angle. Alright, the rest of these are on the answer key, so just look and just keep an eye out for the mistakes within the worksheet. I think I corrected them on my answer key, but just keep an eye out for that, okay? So, we will see you later. Say bye, Arnold. Arnold, say bye.
Goodbye.